is Dr. Mary Louise Hill, and she's a professor of geology at Lakehead University. So, Dr. Hill, are you in Thunder Bay or Aurelia?
Yeah, I'm in Thunder Bay. Who knows where Thunder Bay is?
Oh,
Oh, I think some people in Woodstock know. Let me know.
that is quite a ways away, so it's great you can join us from anywhere in Ontario. So today's call with Dr. Hill is about rocks. And I know the campers are making some tabletop volcanoes. I don't know if
Wow.
anyone's done that this morning yet or if they're doing it this afternoon, but they'll be doing that later, maybe. So before we get to some of the campers' questions, Dr. Hill, could you tell us a bit more about, how you study rocks and what you're learning about rocks in your research?
Yeah. So I'm a geologist, and geologists, we say we study the earth. So we spend a lot of time looking at rocks because the whole earth is made of rock, right? It's a big ball of rock. That's what our planet is, orbiting around the sun. It looks all blue because there's water on top of the rock. That's what the oceans are, just a layer of water on top of the rock of the earth. But mostly it's just rock. So when we study the earth, we do spend a lot of our time studying rock. So I'm a field geologist. What I do when I'm not talking to you here indoors is I go outdoors and I walk around in the forest up north of Lake Superior, where Thunder Bay is, and I study rock in the field, and I'm helping geologists find gold so they can build new gold mines, which helps for the economy of Ontario. We all get to share in the wealth when we find gold mines in Ontario. That's what I do. So you guys are making volcanoes. That's interesting because volcanoes make rock. Volcanic eruptions make igneous rock. And I brought some of the kinds of rock that real volcanoes make. And we know this rock is from volcanoes because it's all full of bubbles. And the volcanic eruption involves air and gas and water bubbling out of the rock. So we get these really nice bubbly rocks formed from real volcanoes. I don't know if your volcanoes are going to make rock today, but they're sure going to make some nice explosions, aren't they?
Awesome. All right. So I'm sure the campers have lots of questions, especially about maybe gold and volcanoes. All that sounds very interesting. So let's go to our first question in Ancaster, perhaps. Does a camper in Ancaster have a question for Dr. Hill?
So go right ahead.
What types of rocks do you study? Right into there.
What kinds of rocks do you study?
What kinds of rocks do I study? Well, because I work in the field, I study whatever I find. So I study igneous, metamorphic, and sedimentary rocks. But my specialty, my expertise is in metamorphic rock. And that's the rock that started out as a sedimentary or igneous rock, but during a mountain building episode, it got buried deep beneath the mountain range and changed. And it gets changed into really beautiful rock with nice crystals in it, metamorphic rock. And when I look at it, I can figure out that whole history of what happened to it. And here's a sample of a metamorphic rock. Can you see how the rock layers are all folded in that rock? Yeah, and that's the kind of rock that I study, and I try to figure out what caused all that folding, because that rock did that as a solid rock. And I don't know about you, but I can't bend a rock today. They're really strong and hard. But when they're buried, they kind of flow, and they're soft, and they can be folded.
Oh, wow, cool. So let's go to London for our next question. Is somebody with a question there?
Yeah.
Hi.
How do you know what age the rock is?
Oh, that's a good question to ask. That's one of the things we always want to know. If I'm studying sedimentary rocks, this is a sedimentary rock, sometimes sedimentary rocks have fossils in them, like little bits of shell and so on. And if we know the age of that fossil, we can get a sort of rough idea about how old the rock is. But the rock I study up here in Thunder Bay, north of Lake Superior, way up in northern Ontario, it is so old that the only life on Earth at that time was, are you ready for this? Bacteria. It doesn't leave a very good fossil. So we have to use other ways to tell how old the rock is. So we actually sample minerals in the rock, and there's naturally occurring radioactive atoms in the rock, and we look at how long they've been having spontaneous decay, and we measure the age. It's called geochronology, figuring out the geologic age. So it's quite an intensive process to do. Sometimes we send our samples down to London, Ontario, to Western University, and they do the geochronology there for us.
That's where we are.
Oh, yeah. Yeah, right where you are.
Yep, great question.
Thank you. All right, so Woodstock. We'll go to Woodstock next.
Do you know what the rarest rock is?
The rarest rock we probably haven't found yet because it's so rare, right? Sorry, that's a joke. I don't know what the rarest rock is. Sometimes we have rocks that are so unusual that we only see them in one place. We don't see them anywhere else. So, for instance, in the area around Montreal, who knows where Montreal is? Right, in Quebec on the St. Lawrence River. In Montreal, there are some hills, some little round hills. They're called the Montérégion Hills. In fact, Mount Royal, that has the big cross on the top of the mountain right in Montreal, is one of those hills. Some of those hills have some minerals in them that we don't find anywhere else in the world, only there on those hills around Montreal. That's pretty rare, isn't it?
Wow, yeah. Very cool. So Ancaster has asked a question via Twitter. They want to
Okay.
know, what is your greatest discovery?
My greatest discovery. Okay, that's an easy one. I talked about finding fossils in sedimentary rock. Well, one time when I was working out in British Columbia in the Coast Mountains, where all the rock was igneous rock from magma and metamorphic rock that had been buried deep under the mountains and heated up really hot, I was walking along on the mountain ridge. I wasn't looking for fossils because I wasn't looking at sedimentary rock, and I found fossils. And it was really exciting. It was fossils of crinoids. They're called sea lilies that lived on the bottom of the ocean floor. I was way up high in the mountains finding fossils that formed on the ocean floor that had been buried and heated, and they were still there, looking just like the stems of those sea lilies. That was a pretty exciting discovery. I wrote about that. It was published in a journal, and people from all over the world wrote and said, wow, that was so interesting to find, and ask questions. People still ask questions, and that happened years and years ago. That was fun,
Yeah.
and that was in Canada.
Yeah, that's so cool. So did you get to take one of the fossils, or are they still there in the mountains?
Good question. I was working for the Canadian government, and when you're working for the government on a mapping project, all of the samples belong to the government of Canada. So I guess I can say those are our fossils, and they're being kept in a collection in Ottawa. And when somebody wrote to me and said, I'd like to study those fossils, I had to just direct them to the big library of rock samples that's in Ottawa. And they dug them out. They're all labeled with numbers, and they pulled them out so that this geologist could study them again.
Oh, cool. All right, let's go to London for our next question.
Hi.
So, if a rock has a radioactive element within it, what happens to the rock after the element starts to decay?
Oh, that's a really good question. So these radioactive elements, they're just like one little atom within a crystal. When it decays, it can cause damage in the crystal right around it, and it also generates a little bit of heat. But otherwise, if you're just looking at the rock, it looks just fine. But that little bit of heat is important because do you know that the earth is hot? If you go deep in the earth, like deep in a mine, you can feel that it gets hotter and hotter and hotter the deeper we go. And part of that heat in the inside of the earth is heat created by those tiny little radioactive decays in the radioactive elements. They keep the earth hot. So that's one of the main byproducts of that radioactivity is creating the heat, what we call the geothermal heat of the earth. Some of the
Oh,
heat of
wow.
the earth, though, is just left over from when the earth formed. The earth formed 4.5 billion years ago, and then it was impacted by a big planet-sized impactor and melted, and all the heat from all those collisions, the earth still hasn't finished cooling down from that. It's still cooling from when it formed by collisions.
Okay, thank
That's
you.
Oh,
interesting
wow.
too, isn't it? Yeah, it's really cool. I think you guys are
Yeah.
going to become geologists when you hear all this stuff.
Yeah. Um, yeah, that was a great question too. Thanks,
Yeah,
to a
really
camper
good
here in
question.
London. Yeah. So let's go to Woodstock for our next question. Is there a camper in Woodstock with a question for Dr. Hill?
Do you study all the types of rocks?
Yes, I do. And so what, I study all the different kinds of rocks, mostly the metamorphic rock, but if a metamorphic rock starts out as a sedimentary or igneous rock, so if I want to be able to figure that out, what it was before it was metamorphosed, I have to know all about sedimentary rocks and all about igneous rocks too. So I make sure that I keep up and I study those. And one of the ways I study, well, I can read about them, but the best way for me to study the other kinds of rocks is to go on lots of field trips. So when I go to a conference, instead of just sitting in a room and listening to people talk, when I go on a conference, often it's called a field conference, and we put on our boots and our field gear and our backpacks with our lunch, and off we go out in the field and we look at all the different kinds of rocks and we teach each other about those kinds of rocks. So it's a pretty fun job because I get to go out in the field a lot. And I'm a professor, so I teach geology to the university students. And on the very first day of lab, we go out in the field. We walk out on campus at Lakehead and we look at some rock in the field. And we spend a lot of time outdoors camping and looking at rock in the field. It's a lot of fun.
Yeah, that does sound like a lot of fun. It sounds like maybe you've traveled maybe all over the world as well, like, or
Yes,
is
I
it?
have. Yeah.
Yeah.
No, I travel. I mostly do my research in North America, but I've traveled all over the world. I was at a conference, a field conference in Spain a couple of years ago in the Alps of northern Italy. I've been to Nepal, to Mount Everest. I've been to England. I've been all kinds of interesting places. Yeah.
Oh, very cool. So let's go to Ancaster for our next question.
Okay.
I see a camper coming up here.
How big is the largest rock you have ever worked with?
That's a fun question. How big is the largest rock I have ever worked with? The largest rock, I guess, is the planet Earth. It's a great big rock. Yeah, when we see rock in the field, all we're seeing is that upper part of the big rock that's the planet Earth. And when I take a sample, when I have like a little piece of rock like this, I'm just breaking that piece of rock off of the planet, which is one big solid rock. So that's the way we think about it, is that the whole Earth is the big rock, and all we're looking at are little samples off of that rock.
Oh, cool. Good
Mountains are,
question.
yeah, mountains are even bigger samples, aren't they? They're like great big pieces of rock sticking up through the soil and the water and the vegetation. Because that's really what happens with the Earth. It's all rock, but there's all kinds of other stuff on top of it, right? Like oceans and soil and buildings and universities and houses and parking lots and forests. That's just sitting on top of the solid rock of the Earth. Yeah.
Yeah, that's a cool way to think of the Earth, actually. You don't always think of it as a giant rock, as one piece like that. Cool. Let's go to London for our next question.
Hi, London.
rocks formed? How are rocks formed?
Well, how are rocks formed is a really great question. Different rocks are formed in different ways. So igneous rocks crystallize out of magma. Magma is molten rock that comes up out of the earth, and it crystallizes to give us igneous rocks. Like this is a basalt that formed from a volcano. Sometimes the magma doesn't get all the way to the Earth's surface and it cools and crystallizes underneath. That's another way igneous rocks form. Sedimentary rocks form from sediment that gets eroded from rock that's exposed at the Earth's surface to turn it into sand or silt, and it gets carried by water or wind and deposited someplace else, buried and compacted, and that forms a sedimentary rock. And metamorphic rock, my favorite kind of rock, it forms when another kind of rock is buried very deeply, so it's heated up by the heat of the earth and it's under pressure and it changes into a new rock with different minerals in it, beautiful crystals of different minerals in it. So rocks form all different kinds of ways. Sometimes we talk about the rock cycle, which is the way that the same material that makes up one rock can be turned into different kinds of rock over geologic time. And when I say geologic time, I don't mean like days or weeks or months or years. I don't even mean centuries or millennia. Geologic time, we talk about millions of years and hundreds of millions of years and billions of years, because these processes are very slow. But they do change the earth and make new rock all the time. Good question.
Yeah, great question. So we have time for one more question. So let's go back to Woodstock for our last question. I see a hand up there.
How many gold mines are in Ontario?
How many gold mines are in Ontario? Oh boy, I don't know right off the top of my head. I know exactly how many there are in northwestern Ontario where I work. There's one big operating gold mine at Red Lake. It's one of the richest gold mines in the world. There's a mine called Musselwhite Mine. It's just a fly-in mine in the middle of the boreal forest. There's a big mine called Hemlo Mine on the Trans-Canada Highway north of Lake Superior, near the town of Marathon. There's a mine near Wawa, Ontario. So those are the active gold mines in northwestern Ontario. But when we go to northeastern Ontario, the area around Kirkland Lake has several gold mines, and the area around Timmins, Ontario has also many gold mines. So just those two little regions have as many gold mines as all of northwestern Ontario. So altogether, I don't know the exact number, but we're probably talking about 20 or 30 active gold mines in Ontario. Yeah, we produce a lot of gold in Ontario. We're
Yeah,
well known
that's
for it.
something. Oh, yeah, I didn't know that. Something I learned today. Thanks.
Yeah.
So, thank you very much, Dr. Hill, for calling in today. I thought we had a great discussion about rocks, lots of great questions from the campers. So, thank you very much.
My pleasure. It was really nice to meet you. Enjoy camp, guys. Have fun.
Yeah.
Bye.
Bye.